Okay, so here are just some additional notational issues that you will encounter on Rogowski, page 139. Sometimes it's a little annoying that they have all these different notations for the same thing, but they actually each has its sort of value in different contexts, and you'll see that to be the case. So we're going to look at first this weird thing that they did, number 8, right? So first of all, d dt, t to the negative cubed. Okay, so if I say d dx of f of x, that's the same as writing the derivative with respect to x of f of x, right? So for example, I can say the derivative with respect to x of x squared is equal to 2x, right? That's just the notation. Now, the other thing that they've got that's really useful is this vertical line, and then they put a value. We're going to use this notation a lot. And what it means is whatever expression you have here before, you evaluate it with this value of the variable that is specified. So when it says the derivative with respect to t of t to the negative cubed evaluated at t equals 4. All right, and that's how you read that. The derivative with respect to t of t to the negative 3 evaluated at t equals 4. All right, so what I would do to do this is I would first rewrite my, oh, actually I don't have to rewrite it, it's already rewritten for me. So I'm just going to say the derivative of t to the negative 3 is negative 3t to the negative 4th, right? That's just my power rule. Multiply the negative 3 in front, drop it 1. But then I have evaluated at t equals 4. So that just means plug the 4 in for the t. So I have negative 3 times 4 to the negative 4th. So hopefully you can figure out that that means negative 3 over 4 to the 4th power. Let's see if I know 4 to the 4th power. It's 64 times 4, so it's going to end in a 6, so it's 256, negative 3 over 256. See, it's useful to know your powers of 2. Any power of 4 is also going to be a power of 2. So if you know your powers of 2, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24, 20, 48, 40, 96. Right? Know your powers of 2, especially if you're doing computer stuff. All right, so that's how I got 4 to the 4th power is 256 without using a calculator. All right, do you want to use a calculator? Sure, you can use a calculator, but you know, the more you take the elevator, the less strong your legs are going to be. And the more you take the stairs, the stronger your legs are going to be. If you're on the track team, don't take the elevator, all right? You are on the track team of math. Don't take the elevator unless you have to. Sometimes you have to. I got a cart, full of stuff. I got to put it on the elevator, okay? Sometimes we have to use the calculator. But if you don't have to, don't. Develop your mental skills. All right, now, the other one I wanted to do was number 38. So this is number 8. Number 8. And then I wanted to look at number 38. Yeah, basically it's sort of the same thing, but now, so now see how they've got dp dv? So that's it's like dy dx. So it's saying the rate of change of pressure with respect to volume is the application here, by the way. This is a physics idea. So it's just telling you that P is acting like the Y and V is acting like the X. So we're going to do dP dV. So this is like Y equals 7 over X. All right. So we're doing dP dV evaluated at V equals negative 2. I guess that's supposed to be a comma. I'm looking at that what is this thing? It's like they put an apostrophe on the 2. No, I think this is a comma. I mean, would have been nice to make it a semicolon instead and also space it out a little better. It looks like 2 prime. What is that? That's just a comma, okay? So we have P equals 7V, okay? So the first thing I'm going to do is find out what dP dV is. So this just means I'm doing the derivative of 7 over V. So first I have to rewrite that and say, oh, that's 7V to the negative 1 power. And then so dP dV, the derivative of that, is negative 7v to the negative 2 power. All right, that's what dP dV is. All right, and then so dP dV evaluated at v equals negative 2 is going to be negative 7v to the negative 2 evaluated at v equals negative 2. Right, so that, sometimes you just put the negative 2 in parentheses is another way to write that. But they wrote it this way. It's a good idea to get used to this notation. The vertical line just means evaluated at this value of that particular variable. Okay, so then we're going to say that this is equal to -7 times -2 to the -2 power, which is equal to -7/4, right? It's -7/4. You can just leave it -7/4. Okay, so those are just some of the weird notational things. Apart from that, you should be able to do all of the homework, which I mentioned in the previous video, is page 139. This is Rogowski, page 139, number 7 through 43 odd, except for number 19, 29, 31, and 41, which, by the way, we're going to learn how to do on Thursday. All right, so there you go. That's your homework. Good luck with it. Have a ball.